Alright, I'm making a little video here to test out Eastwood's Internal Exhaust Coating. I am working on this 1994 Lexus SC400 1UZ V8 engine, 4-liter V8 engine, and I'm swapping it into a 1987 Toyota 4Runner in place of a 2.4-liter 4-cylinder. One of my concerns in this swap is heat, underhood temperatures. I was researching ceramic coating. I don't like fiberglass header wrap. Ceramic coating is expensive and not most places don't do it. And so I stumbled across Eastwood's Internal Exhaust Coating, which they claim does something similar to what a ceramic coat it would do by keeping the heat in the exhaust and in the air in the exhaust, and therefore pushing it out the tailpipe, out away from the engine bay. So I thought I'd give it a try, and this seemed like a really good way to test it because I was doing some things with this engine that allowed me, required me to start it and run it on the stand here. So I've already made the video, and I will edit it in here, of a control test. I ran the engine for 20 minutes or so until an infrared temperature gun pointed at the thermostat housing here indicated about 160 degrees, as I recall, Fahrenheit. And then I started pointing it at the manifolds to see what temperatures we were seeing. And both sides. And the idea there, like I say, is a control to make sure that this engine warms up, that both sides warm up equally, as it should. And it turns out they do. As I recall, and I'll show the video here, I'll edit the video in here in a minute, but as I recall, I gotta think about it, other side, whatever, the side that I ended up coating actually was a little bit hotter on the day of my control test. Not by a ton, but by a little bit. So there's a little intro, and I'll edit in the clip of the control test. Seeing 160 or so on the housings, or getting a little drip of some fresh coolant. Check those headers, those manifolds. Between 400 and 430. How about this one? So that shows that the two sides do warm up pretty similarly. Gives a bit of a control. You may have noticed there was some snow on the ground. It was much colder then than it is now. But I've had some time to get the project to the next phase, and part of that was to paint. I opted to just paint one manifold so that I could do a comparison again. So here's what I did. These are 15-year-old manifolds. This is what the one on the other side looks like. They're greasy and kind of rusty. Actually, not too bad, all things considered, but not great either. So I soaked these. I actually soaked it unsubmerged in Simple Green degreaser, literally for a couple of days. Mostly just because I'm busy, and that's just how long it was before I got back to it. But a couple of days submerged in degreaser, let it rinsed, dried, then submerged in. I used Pour 15 Metal Prep. I like Pour 15 products as well, so I have this stuff around, and that's what I used. Took me about 2 gallons in a well, not quite 2 gallons, but in a smallish bucket. Does this say what the capacity is? It is a 2-gallon pail. And I was able to submerge it, truth be told, half at a time. I had to flip it over. To etch, to dissolve and treat the rust that was in it, and to etch the bare metal for best paint adhesion inside and out. Obviously this product we're concerned more about the inside of the pipes, so a mechanical cleaning was going to be more difficult. So let's talk for a minute about the product. There it is, Eastwood's Internal Exhaust Coating. They also comes as a package deal with their spray nozzle. They call it a 360-degree spray nozzle. You can see it has 4 holes. So it's not so much 360 degree as it is 0, 90, 180, 270. And it kind of shows when you go to apply it. It comes out in 4 distinct streams. They also have their own degreaser painting prep product. I mostly bought that to clean the nozzle because I knew there was going to have considerable time between painting the 2 sides. I wanted to make sure that the nozzle got clean so that I could use it again after some time. So then when I applied it, it came out very thin. It sort of made a mess. You can see a little bit that it dripped out the end here down the flange. It's too thick in some places and too thin in others. But I put it on thicker than I would have liked to, and tumbled the manifold around some of that stuff, and got some decent coverage, and was pretty happy with it. I opted, because it was so thin and dribbly, it had sort of dribbled out in some funny places, so I put a real thin coat on the outside too. You can see it's not perfect coverage. There are heat shields that are going to go over this as well, so I'm not too worried about it being perfect. But now a manifold this size, I bought 2 cans. This one's probably a third of it or so is left, if I had to guess, so decent usage. I did use 2 separate coats on the inside, and then, like I say, 1 thin coat on the outside. Might have been able to do both with 1 can, but I'm glad I don't have to. So the next test was with very little change in the setup on the engine. I was doing modifications to put a transfer case on the back, as mostly was what was happening between these 2 tests. I painted the valve covers, I did spark plug wires, and what else? That was about it, really. So the engine has changed very little, using the exact same ECU, the same management, the same fuel pump, the same fuel even. So this should be a pretty accurate test. And I ran it again, probably 15-20 minutes. I ran it until I was seeing 150-ish degrees on the upper coolant passages, that being the one that feeds the thermostat, as well as the one across the back. They both bridge between the 2 heads. And then I took readings on both exhaust manifolds. And you'll see the coated manifold was noticeably cooler. 60, 80, maybe even 100 degrees cooler. So engine's about 155. This coated manifold let's just stay up here. So I'm sure ceramic would be better. I have seen engines exhaust with header wrap on it that you could put your hand on that are 100 degrees. I wasn't expecting results like that, but any little bit just to help keep the heat out of the engine bay, help move it along, would be beneficial. So I'm kind of impressed for a product that I didn't see from any other manufacturers. I was afraid that was an indication of a snake oil, but it seems to have done pretty well. I'm going to coat the other side, and the next big project is to stuff this beast into the truck, and we'll see how it goes. I'm even thinking I might paint the heat shields with this stuff, just to help keep it out of the engine bay. So yeah, that was my findings. Hope you find this interesting, and maybe you can use it in your own project.